Show me the cold start rate for my Lambda functions. There, no SQL, no dashboards to hunt, just ask. This is the promise of AI-powered observability, natural language queries against your production database. The demos are impressive. Watch AI correlate latency spikes with database saturation. Watch it find the root cause in seconds. Impressive, isn't it? But that's where the demo starts to fall apart. The tools work brilliantly on standardized telemetry, HTTP status codes, pod restarts, connection pool exhaustion, the commodity observability layer that we all share. But this is table stakes. This is the observability equivalent of the code compiles. Today, I'm going to show you how to build an AI-powered log analytics tool. And more importantly, I'm going to show you why documentation is now more important than ever. Hi, I'm Jack Neely, and I'm an independent observability architect and owner of Cardinality Cloud, LLC, where observability is leverage, not tax. Some guy on Reddit said I looked like Danny DeVito. I'll take it. He's a national treasure. Today, we're building an AI-powered log analytics tool and discovering why documentation is more important than ever in our AI-driven world. So what are our goals for today? Specifically, we want to be able to look at Lambda logs that we've generated with natural language. These Lambda logs will have business logic encoded as structured logging in them, and we want to be able to query for not only things like cold start rates, but business performance, business logic and analytics. We will know that this works when we can query this data with natural language. We also want not to double our observability bill. We're going to use the same ClickHouse-based setup that we used in the cheap log analytics episode. Same ClickHouse, same S3 bucket, same AWS IAM roles and policies. We're going to add an MCP layer to bridge the gap between ClickHouse and our AI agent, which is Claude. This is definitely relevant to your operation, especially if you're using Lambda logs, because understanding Lambda performance is cost, is your budget. And using and understanding how to build and integrate AI-driven observability practices into your existing setup is going to save you a fortune. I did this in about a day. You can too. So the architecture pipeline that we're going to set up is relatively simple. Lambda logs flow to CloudWatch. We're using the CloudWatch export S3 function to publish these logs in S3. ClickHouse reads these logs via the S3Q table engine. The MCP connects ClickHouse to Claude. I'm not going to walk through every line of SQL and all of the configuration here because it turns out there was quite a bit. I've also have a companion blog article that goes with this YouTube video. Links in the comments. So if you want the exact configuration and SQL schema that we're using, it's right there for you. The schema is kind of really the heavy lifting part. It does do a lot of shaping of the log data. And really shaping that I would do with any log data source, not just Lambda logs. But not only does it parse the timestamps correctly, does it look for the Lambda report line and parse those fields and those cold start numbers and memory numbers correctly. It also includes a JSON data field and finds any JSON structure embedded in the log line, pulls it out, parses it, and puts it in that JSON structure, so we have a place for our structured logs for our business logic. So a quick note on costs. The amount of cost that we're adding to our analytics stack in ClickHouse really just comes down to some additional storage. I estimated that we do about 250 gig of compressed logs a month. That's about 1.6 terabytes of uncompressed logs a month. So that adds about $12 to our ClickHouse bill every month. That's nothing. What dominates the bill, though, is the CloudWatch log ingestion costs. At 50 cents a gig, and uncompressed, of course, ingesting 1.6 terabytes is $800. Well, that blows our budget. There are a couple ways we can work around this in more production setups. In 2025, AWS did launch a feature in Lambda to stream logs directly to S3 at only 25 cents a gig. Okay, that brings us down to 400. If I were using Lambda a lot and depending on these logs in production, I would probably set up an SDK that logged directly to a AWS Kinesis stream. Kinesis, of course, also charges by the gig, but we're down to about 12 cents a gig. There are other options as well, including just having Lambda write log data to S3. So there are lots of ways to work around that particular issue and get our budget back down where it should be. So don't fall in the AWS observability trap either. Okay, let's look at our MCP integration. This is really where things start to get interesting because we can get Claude connected directly to ClickHouse. The setup is relatively simple. ClickHouse has an official MCP server in Python that they recommend. There's instructions for setting it up on the ClickHouse site. I even had Claude tell me how to do it. I used UV to control the Python module and get that installed. Of course, there's a bunch of environment variables as well to handle authentication. Again, these details are in the blog post if you want the actual nitty-gritty details there. So once we have the MCP server integrated with Claude and Claude configured, restart Claude code. We can test that the MCP server is working with the /mcp command. And then we can really start doing some interesting things. Claude, show me the cold start rate. Claude generates the SQL, runs it, formats the results, and also includes some complementary data alongside it, like the percentile measurements of how long that is for all of my cold starts. So it really starts showing useful information pretty quickly, provided, of course, it has looked at the schema enough to figure out, hey, these are Lambda logs. And it's easy to tell Claude, hey, these are Lambda logs in the Lambda log table. Here's what to expect. And this question about cold start rates is not something that CloudWatch answers natively. There's no widget in CloudWatch on an AWS dashboard that tells you what your cold start rate is. So the fact that we can just ask Claude and we get the answer really starts to add value that you can see. We can also ask questions like, what's the P99 latency this week? Which Lambda function has the most errors? Show me all the invocations that took more than 500 milliseconds to complete. All natural language, all almost instant answers. This is where most AI observability demos end. Congratulations, it works, it looks great, ship it. But there are problems. Try asking Claude, show me the high-value leads it didn't convert. What's the average observability spend for users who requested a report? Find calculation events where the 3-year savings resulted in more than $1 million of savings. Now, for your context, this Lambda is part of how I monitor lead generation on my website. But Claude doesn't know this. It doesn't know what's in the JSON data. It doesn't know what savings per 3 years in the JSON field means. It doesn't know that a calculation tracked event followed by an ROI generated event means I've got a customer that's converted. It doesn't understand that my business cares about the difference between an engaged customer and a converted lead. This is the AI demo trap. AI observability tools work brilliantly on the commodity observability layer, these HTTP codes. latency percentiles. But for your business logic, they fall apart on what actually matters, which means these tools will gladly identify that there is a problem. But why? Getting you to the root cause is just as unobvious as it has been before. So there's a missing piece here, and that is documentation. What I did was create a Claude skill and built out this skill file with Claude's help, of course, to teach Claude my exact schema in ClickHouse, what each field meant, the fact that the JSON field existed, that's where my custom business logic would be. I showed Claude what my application would emit as far as that custom business logic. There are a couple different data structures that my Lambda admits depending on what happened, and I showed Claude what those were and what they meant. I gave Claude a bunch of examples in SQL of common questions and how to figure it out. So once I created this skill and had Claude start using it, Claude got a lot more interesting. The best part about the skill is once I had context built up in my Claude code session, it really helped write most of that Claude skill. So with this context, Claude now understands what the observability spend field in my JSON data means. It understands that a calculation tracked event that's not followed by an ROI generated event is a lost lead. It can answer basic business questions. It can answer advanced business questions. Here is the deeper insight. None of this is new. The Claude skill just isn't for AI, it's our documentation. Maybe in a more concise format, but it's the documentation that we've needed all along. We document our code. We have automated tools that help us document our APIs. When we deal with SLOs, we document those and what availability means. But do you document your telemetry? Do you know what the telemetry around your custom business logic actually means? When a new SRE joins the team, they need to understand the telemetry. They need to know what the dashboards mean. When you're debugging incidents at 2 a.m., it's great if Claude already has the context available to help you out. So we understand what checkout flow version equals 3 actually means to the business. This was true before AI. This is still true today with AI. The Claude skill file becomes a shared library in Git, available to our entire team. This allows our entire team to have consistent AI interpretation of the telemetry and all of these events. The institutional knowledge no longer lives in somebody's head, but in a format that Claude can understand. The only real difference with AI is that it will confidently hallucinate if it doesn't have the right context. Next, I'll be claiming that AI invented runbooks or some place to put our documentation. Maybe I'll call it a wiki. The real lessons here. AI-powered observability is not a magical fix. Claude can correlate latency spikes and parse Lambda report lines all day long. This is the easy part. The hard part is the same hard part that we've always had: producing quality data and documenting what it means. This problem isn't new. Most teams didn't rigorously document their runbooks and their telemetry before AI either. The new engineer still struggles to understand the telemetry and the dashboards. The on-call rotation still has tribal knowledge in each of their heads. Everyone is hoping AI will magically solve this, or at least paper over the situation enough to be somehow useful. Or that with enough fine-tuning or model training, AI will be generally useful, or at least coupled with a tool that's able to shove your wiki data into a RAG and make that context available. But AI isn't a substitute for good engineering practices, but it will amplify the ones you have, whether they're good or bad. Let's wrap up. Today, we built an AI-powered Lambda log analytics solution. Natural language queries against production data, no SQL required for day-to-day operation. The best part, it even worked. But the real insight isn't technical. It's this. AI observability tools are only as good as your documentation or the context that you can provide. They excel at standardized telemetry as this is easily trainable. They struggle with your custom business logic unless you teach them what it means. The Claude skill file, the schema definition, the business context, that's not optional. That's the whole game, just as it was before. Observability is automation for your understanding. Like all automation, garbage in means garbage out. If you want help building this kind of observability solution, or figuring out which documentation that you really need, I can help. Link in the description.